Welcome to the course devoted to subnetting and its bearing on the security of the whole computer infrastructure. Let's start from the very beginning. For two hosts to be able to communicate in computer networks, IP networks, they must have unique IP addresses. If two hosts are in the same network, they can communicate with each other directly. If two hosts are located in remote networks, all communication between them takes place through routers, devices that are responsible for connecting individual networks. This means that by dividing a company into smaller subnets, you gain the ability to control the packets transmitted between hosts. The first advantage of this solution is that the packets will always be sent by routers that you manage yourself. You don't need to use routers when you divide the network into subnets. Instead, you'll use a special kind of routers, namely firewalls. The router forwards packets. It must reject erroneous packets or those that exceeded their lifetime. Firewalls, on the other hand, are routers that filter forwarded data. This enables you to improve not only the efficiency, but also the security in a direct way. If you remember lectures devoted to the consumerization of IT, you will know that a corporate network encompasses more than just devices in the company's headquarters. At present, a corporate computer network can include users' temporary whereabouts. These are very often users' homes, because they communicate with the network through mobile devices. Such a network can hardly be regarded as trusted. Not all administrators know what devices are connected to their networks. Back when a local corporate network included 6 hosts and 2 servers only, the distinction between the secure corporate network and a dangerous internet was reasonable. Right now, a corporate network encompasses every single device that any given user connects to it. Therefore, the security level of such a network is similar to the one of an external network. It needs to be divided into smaller segments. It will allow us to monitor packets sent over a network, and in particular, to control the availability of selected hosts. If you use firewalls to create subnets, then computers in subnet A will be available only for trusted hosts located in subnets B and C. Using firewalls instead of routers, you gain the ability to detect and prevent attacks such as those that you see in the picture below. What we see there is a network communication between two clients, first intercepted and then reassembled. If we reassemble such communication, that is, see what data was sent in a TCP connection, it will turn out that it was a computer trying to connect to a web server in order to download a file root.exe. You wouldn't like your computer to download and run such a file. The application layer firewalls offer the ability to monitor the network. These firewalls employ more than just simple rules, such as that a computer from network A can communicate with a computer from network B on port 80. There are firewalls that examine only protocol headers, but also data transferred by these protocols. Let's focus again on the IP protocol, on its 4th version. The simplest method of subnetting is classful addressing. As you can see in the picture above, 3 classes are used, A, B, and C. Class D is used for multicasting. Its addresses are reserved for future use. Classful addressing is very simple. To distinguish a network address from a host address, you look at the first bits of the most significant byte. This is the first part of the IP version 4 address. If the first bit of the octet is 0, then this is a Class A address. In decimal notation, these would be values ranging from 0 to 126. The value 127 is the loopback, and any address starting with 127 points out to your local computer. The same method applies to higher classes. If the address belongs to Class B, the value of the oldest bit must be 1, and the next one -0. This means that the first two octets constitute the network address, and the next two, the host address. If the first two bits of the last octet are set to 1, and the third one is set to 0, then the IP address belongs to class C. In such a situation, the first three octets constitute network address, and the fourth one is a host address. It's a clear and simple principle. Unfortunately, such addressing is very inefficient. Many addresses are wasted. In the case of IPv4 protocol, you cannot purchase just any address if you want to achieve proper routing. You always have to have a network address. Even if your network includes 6 computers, you still have to buy a whole Class C network address. You have to pay for all of the 256 addresses, even though you'll use only 8 of them. The solution to this problem is classless interdomain routing, CIDR. It utilizes the fact that the network address and the host address don't need to be divided into individual octets. One part of an octet can define the network address and the other the host address. To allocate these bits, a CIDR mask is needed. I'm sure you remember from the previous lectures the CIDR addressing scheme. The complete network address must come before the host address. The only correct masks are shown in the table below. Zeros and ones cannot appear interchangeably. In a mask, ones indicate the network address and zeros indicate the host address.